Today we are going to be doing the 2012 AP Calculus AB free response question number 3. Let's start by reading the background information. Let f be the continuous function defined on the interval -4 to 3, whose graph consisting of 3 line segments and a semicircle centered at the origin is given above. Let g be the function given by g of x, and it has this integral. We're going to start by underlining all the important information. Underline continuous, that's key, the interval, the line segments, semicircle, and g of x. These are all extremely important to this problem. Let's start on part A. Find the values of g of 2 and g of -2. So we're going to plug these into this equation. G of 2 is the integral from 1 to 2 of f of t dt. And that's just equal. We have from 1 to 2, the integral of f of t, this is f. We know that this is a triangle, therefore base of 1, height of 12, or not 12, 1/2, height of 1/2. And because it's below the x-axis, it's going to be negative. So we're going to do base times height, 1 times 1/2, over 2 to find the area. And the integral is going to equal -1/4. Let's find g of -2. Same thing, plug in the values. Now the bounds are a bit different. It goes from a positive number to a negative number. I'm going to switch it around so it's a little bit easier. Now it's going to be I put a negative out front, and that allowed me to switch the limits. And so this has 2 parts. The first part, it's a triangle above the x-axis. Second part is the semicircle below. So we're going to start with the triangle above. We know that that is 3, height of 3, base of 1. It's going to be 3 times 1 over 2. And since this is, now we're going to go into the semicircle, it's below the x-axis, you're going to subtract it. We're going to have, it has a radius of 1, so pi r squared divided by 2, pi 1 squared over 2. And put a negative out front. And then that is going to equal pi over 2 and minus 3 over 2. Let's move on. Those are your 2 answers. Move on to part B. We're going to find the values at derivative of g of -3 and second derivative of g of -3. So let's start. We know that the derivative of g of x equals f of x. So plug in those values. And go to the function. -3 up, that's at the value 2. And then moving on to the second derivative of g, we know that's equal to just the derivative of x. Plug the values in again. And now you're finding the slope at f of -3. Go -3 up the slope at this point. Well, the slope's the same along this whole line, so you can do anywhere. Rise over run goes up 1, over 1 to the next point. 1 over 1 has a slope of 1. That's the value there. Let's start on part C. So we're going to be finding the x-coordinate at the points where g has a horizontal tangent line, then determining whether g is a relative minimum, maximum, or neither at this point. We know that there is going to be a horizontal tangent line where the derivative of g of x equals 0. That means where the f of x equals 0, there's going to be a horizontal tangent line. F of x is equal to 0 at 2 points, x equals -1, and x equals 1. So there are horizontal tangent lines at those 2 points. I'm going to put the explanation down. This is the first explanation of this problem. we've determined the horizontal tangent lines. The graph of g has a horizontal tangent line where the derivative of g of x equals f of x, which equals 0. This occurs at x equals 1 and x equals negative 1. So you need an explanation. It has to be along the lines of this. Let's get on the second parts of this problem. So now we have to determine the horizontal, or whether it's a relative minimum, maximum, or neither. Let's start at x equals negative 1. So f is changing signs from negative or positive, and then it's changing to negative. That means that g of x is going to have a relative maximum at that point. Now I'm going to write the explanation for that down. This is a second explanation. Derivative of g of x changes signs from positive to negative at x equals negative 1. Therefore, g has a relative maximum at x equals negative 1. And then let's go on to the last part. Let's find the relative max, minimum, or neither at x equals 1. So this f does not change signs. As you can see, it goes from negative, hits 0, and continues to negative. Therefore, because it doesn't change signs, there is neither a relative maximum or a relative minimum. Let me put the explanation down for that. So this is the work for this part. We know that derivative of g of x does not change signs at x equals 1. Therefore, g has neither a relative maximum nor a relative minimum at x equals 1. Now for the last part D of this problem. So part D is asking for, on the interval from negative 4 to 3, it's asking to find all the values of x for which the graph of x has a point of inflection, or the graph of g has a point of inflection. So we're going to know that. That's going to be, or we're going to know this when the second derivative of g of x, which equals the derivative of f of x, changes signs. We're going to know that the derivative of f of x changes signs when the graph of x has a horizontal tangent line. So there are horizontal tangent lines. There can be one at x equals negative 2. Go across like that. There can be one at x equals 0. Goes across like that. And there can be one at x equals 1. Goes like that. So those are the 3 points of inflection. And that is because the derivative of second derivative of g of x equals the derivative of f of x, and the derivative of f of x, that's changing signs at these values. So let's write that down and provide an explanation for that. So this is an explanation. The graph of g has a point of inflection at each of x equals negative 2, x equals 0, and x equals 1. Because the second derivative of g of x changes signs at these values. So that is the whole problem and each of the explanations. Make sure you explain your answers, because if you don't, you're going to lose a lot of points. And this problem, I'd say, is one of the harder problems. It's very conceptual, and you need to know exactly what the problem is asking for, and you're going to need to know a lot about derivatives and second derivatives and how to explain that and give proper justification. So if you need any more help with these types of problems, I've included links in the description of the video to problems, or AP Calculus Problems 2002 number 4, 2004 number 5, 2011 number 4, and 2014 number 3. There are links in the bio to YouTube videos describing these questions, and these questions are the same type of question as this one. So look in the bio, and if you need extra help, you can look at those videos, and hopefully they will help you out.